Our next speaker is Michael Dudas. Michael is the owner of Dudas Engineering LLC, which is an environmental and civil engineering firm that provides specialized civil engineering and constructive services. His firm's water resources work includes dam and levee design, dam inspections and investigations, and stream stability and restoration. Prior to establishing Dudas Engineering, he worked for the Illinois Department of Natural Resources in the Abandoned Mine Land Reclamation Division and Land Reclamation Division. An issue of great stability is, or great interest rather, is the stability of the coal ash impoundments, which currently separate 3.3 million cubic yards of coal ash from this river. What factors affect the stability of these structures, and do we have a reason to be concerned if they're left in place? Well, Mike's here to talk about that and the threats of long-term stability of the coal ash impoundments. Mike?
Michael Dudas with Dudas Engineering, I'm a professional engineer. EcoJustice invited me out here to kind of just go over some points. They'll be brief, just kind of provide some ideas. So I'm glad EPA is here, just kind of talk about the CAP or the corrective action plan. And just consider some of these things. You guys are experts and look forward to seeing how you guys resolve it. One thing I want to talk about is actual impoundment itself. The term landfill got thrown around, and there's a big difference there. An impoundment is constructed with a dike system, and then what's inside is hydraulically placed. So it's in the presence of water, so it's less controlled if you were to just build like a landfill. And it's really important with fly ash and coal combustion waste is that they don't behave exactly like typical soils. They have different properties just based on the coal source, the preparation, the power plant, and the combustion temperatures themselves. And one of the important characteristics, there's many, is specific gravity. Oftentimes it can be lighter than, and specific gravity really helps compare, it's kind of its weight relative to water, so how heavy or lighter it is in the water. It's just a kind of a property. And lower specific gravity can result in lower densities, higher moisture content at a given void ratio, and the potential for reduced stability with respect to seepage forces. And that's all important when we look at the inside of the impoundment and consolidation. So as it settles over time, if it's not compacted or controlled, it can be in a loose state and keep it flowable, which is another important factor. So generally with failures, water plays an important role in triggering the slope failures. The water content can reduce the slope stability, and it can drop the factor of safety. So especially being next to a river there is very important. So a common failure that happens in dams, I've heard the term piping or internal erosion. It's a movement of the soil material under those seepage forces, and it can occur when the gradation is such that particles are dislodged and carried along by seepage and drag forces. And so when we talked about the New East ash pit and the mining, it's important to note that when it overlies rock, the material can occur and kind of pipe through those joints or stress relief fractures or where the subsidence occurred that can cause those fractures. And then over time that can produce that channel, that piping, and that's when that movement flows, it can lose that stability. And that's very important. Another important aspect, as I mentioned earlier, and it's been discussed, is the location of the river next to it. The toe of the dam is very important for really large rotational failures. So really the global stability of it, not necessarily sloughing, but the whole impoundment itself. And so it's, it's important to note as it moves and it's eroding, and it removes that toe of the slope, that it's really impacting the entire structure. And so some of the concerns are really the overall and uncertainty in the engineering properties of the coal combustion waste. Even in the URS report, which is a very well done report, all the reports are very good, very informative, so I encourage you guys to read them. But they do mention, the non-uniform conditions can't be determined by the procedures described, and that really the interpretations based on judgment and limited available information. Another aspect that's important relative to the impoundment is how it's constructed. There's different ways to construct these impoundments, but one of them is in what they call upstream, and where they build the initial dike system, and then as they hydraulically place the materials like the coal ash and the fines, it's in an uncontrolled state, so it's purpose is to settle out over time or consolidate itself. And then they actually take the material and they bridge over and push the material over the top of it to create that cap. And it's important because upstream methods can lead to weaker dike foundations and increased probability of sudden or catastrophic failure. So the other aspect I mentioned is definitely the foundation, especially in the new East Ash pit. When we consider that they discussed that it was overlaid on shale and rock, that moisture can over time kind of weaken some of that rock or slaking, so it's disintegration of those shales, which is important to the internal piping that I discussed earlier. And then with the river, it's also important to have, when you're analyzing the floodplain, to really have good cross sections of the whole river to determine really what that high flood can be on that river and how it'll impact that dam. So it's just something like the Stantec report noted, really that it's getting close. Almost 8 years could be up there based on the report. So things to consider when accurately looking at stability on how the river can really impact it in flood conditions. Another issue, I think one of the impoundments is regulated by DNR, the other two are not, and that's really important as far as monitoring goes. So you saw some of the pictures, like the trees on there. Trees are really important. You want to remove those from dams because their root structure can create seepage paths, which also affects internal erosion. And also, even doing bank stabilization, that stream wants to attack those things. So you saw in the picture, some of that riprap kind of got washed away, a little different than a lake as the river pushes it along. So just important things that I hope the EPA considers during their corrective action plan. Thank you.
Thank you, Michael.